This is problem 1 on exam 2 of module 6 in the book Problem Solving Guide for Electromagnetism and Optics. Exam 2, problem 1, 7 resistors are connected as shown. Each one of the resistors has a resistance of 30 ohms. The 12-volt battery is hooked up across AB. What is the current through the battery? There's a good diagram. Let's add a battery. Here's our battery. The current's going this way. Let's add some arrows so we can imagine how the current's flowing through this circuit. Coming up through there, going through the battery, coming down through this one, going across. Current's coming here, splitting here. Some of it's going that way. Some of it's going this way, splits again. Once it gets to here, keeps going around the loop. These two combine. This one goes that way, and then it goes back to the battery. Well, let's try to get the equivalent resistance. So we think about parallel, series. It's clear at the far right, those 3 resistors on the far right are in series. They're in a chain, one after another. Each resistor is 30 ohms. The combination of these 3 resistances is 60 ohms, is 90 ohms. 30 times 3 is 90. So there we go. An equivalent circuit. We took these 3 30 ohms and we made one 90 ohm resistor. Now we can keep going. Here's a 30. This 30 is in parallel with this 90. The current comes in, it can go through the 30, or it can go through the 90, and then it gets back together on the other side. These two are definitely in parallel. We can calculate these guys right here. We can calculate the equivalent resistance. A 30 and a 90 in parallel combine to be 90 over 4, which is 22 and a half. We can redraw the circuit again. Now we have this one resistor representing these 4. This 22 and a half is in series with this 30 and that 30. When resistors are in series, we just add them up. These 3 resistors are in series. They combine to make an equivalent resistance of 82 and a half. So we still have this one over here, which is right across the battery. These 3 combine to be 82 and a half. And we redraw the circuit one more time. Now we have an 82 and a half in parallel with a 30. We can calculate the equivalent resistance like that. That's 330. We can make the denominator 330 ohms. That's the common denominator. So 11 330ths is the same as 1/30. 4 330ths is the same as 1 over 82 and a half. So the equivalent resistance of the entire circuit is 22 ohms. And we can redraw it one more time. There we go. One resistor, 22 ohms. It's the equivalent of these 7 resistors, each 30 ohms. The question asks for the current through the battery. We have 12 volts across 22 ohms. That's 6/11ths of an amp. 6/11ths is 545 milliamps. That's problem 1. Of course, if you're a student of physics and you really want to understand what's going on, you should calculate the current through every single one of these resistors, the voltage drop across every single one of these resistors to make sure it's consistent at each branch. And when you go around the loop back to the battery, any path, you get a voltage drop of 12 volts. That's problem 1.